Hello and welcome to another exam paper walkthrough. We're doing something slightly different today. We are in preparation for paper 2. We're doing GCSE Maths June 24 paper 2H, and this is the paper that I've produced, and I'm calling it a higher tier very likely topics. So these are very likely topics as analysed by First Class Maths. Fantastic resource. They'll be doing their own paper very shortly. And if you find this useful, subscribe if you like. Okay, so this is the paper. It is 97 marks based around very likely topics. This this paper has been produced using the key topics from First Class Maths. So he produced this excellent and comprehensive list of all the likely topics. So he's kind of rated them by stars. I call them highly likely or very likely and a good chance. I've done the good chance as a second paper, so I would strongly recommend you look at smashing this paper first of all, and then when you've done that, start to look at the good chance, because these are sort of very, very likely. These are less likely, but still good chance. Again, this is no guarantee that the topics will come up. It's just a forecast based on past series and the appearances on paper 1. There are a few questions that appear on both papers due to an overlap of skills. So I used these sections, and I produced a group of questions based on these topics alone. What I then did was I used Edexcel's enhanced skills map for higher tier. I selected all the questions that I thought were appropriate, and then I arranged them by mean difficulty. So it should start fairly comfortably and then get progressively more challenging, with the final one being a very only 5% of the country actually got that right in that year. And I would strongly recommend you have some music on in the background. It will definitely help you get through this, and let's start. Okay, so the first question. Mary travels to work by train every day. The probability that the train will be late on any day is 0.15. Complete the probability tree diagram for Thursday and Friday. So I really like these. They normally appear quite late in the paper. And this filling in the tree diagram is, I think, a really nice, comfortable 2 marks. So probabilities need to add up to 1, so this needs to be 0.85. This would be 0.15. We're not changing the probabilities. 0.15, and both of these would be 0.85. And that's it for your 2 marks. And it would help if I wrote 85 rather than just 5. There we go. And then part B, they always tend to ask a second part to this. Work out the probability that the train will be late on at least one of these 2 days. Late on at least one of these 2 days actually means we want this branch, and this branch. This is the only one where it's not late. And rather than work out these, there's nothing wrong with working out these 3 individually and then adding them together. I'm going to do it slightly differently though. I'm going to take away the probability that it's not late on either day. So I'm going to do 1 minus 0.85 times 0.85. Right, hopefully I can bring my calculator in. There we go. So I'm using the FX83, slightly old version. If you've got a more modern one, provided you're familiar with it, it shouldn't really make any difference. So 0.85, and I'm just going to put squared. I could do it twice, but there we go. So I've got 111 over 400. So I'm going to go 111 over 400 before I go decimal, and then decimal 0.2775. Does it ask for a degree of accuracy? It doesn't, so I'm actually going to go for that. 0.2775. Question 2. A new phone costs £679. The value of the phone decreases at a rate of 14% per year. Work out the value of the phone after 3 years. So this is like a compound interest question. If something decreases by 4% each year, then the multiplier here is going to be 0.96. So I'm just going to take the initial value, multiply it by the decimal multiplier to the power 3. And go to my calculator. 679 multiplied by 0.96 to the power 3. So we're looking at 600.76 .7357 dot dot dot, don't round, and then round 600.74. Question 3. ABC is a right angle triangle. Calculate the length of AB, giving your answer correct to 2 decimal places. So if I label that X for now, and now we're using a right angle triangle where we know 2 sides involving 2 sides and 1 angle, so it's telling me it's trig. So I need to I have the strategy of labeling the 2 sides I'm working with. This would be the hypotenuse, the longest side opposite the right angle. This would be the opposite. So that tells me my only trig ratio with an O and a H is the sine ratio, SOH, and I want to work out O. So rearranging that, O is going to be equal to S times H. So I'm going to go, X is going to be equal to 16 times by sine 38, which is going to give me 16 times by sine 38, 9.85058 dot dot dot, to show that I've not rounded, and then I'll round to 2 decimal places, so 9.85. Right, question 4. A box is in the shape of a cuboid placed on a horizontal floor. The box exerts a pressure of 180 newtons on the floor. The box exerts a pressure of 187.5 newtons per meter squared on the floor. The face in contact with the floor is a rectangle of length 1.2 meters and a width of x meters. Work out the value of x. Okay, nice question. Right, so the first thing that we're going to work out is the area in terms of x. So the area is going to be equal to 1.2x. And then we're told, I'm actually going to rearrange this to find the area. So I'm going to say that the area is equal to the force divided by the pressure. So the force, I can put in all my values here. So 1.2x is going to be equal to the force, which is 180, divided by the pressure, which is 187.5. So x is going to be equal to 180 divided by 187.5 times by 1.2. In effect, all I've done there is just divide by 1.2. Could have done that as a separate step, that's absolutely fine. So we get 0.8. Have we got a meter? We haven't. To be fair, we don't really need meters, but because it's implied in the question x meters, so we just asked to find x. Right, just adjusting my vision there slightly. Again, calculate the length of AB, very similar to the trigonometry question that we did earlier. We're involving 2 sides and an angle, so that tells us it's trig. This time we've got the hypotenuse and the opposite again, so SOH again. And we're trying to work out O again. So x is going to be equal to 15 times sine of 23, which is going to give us 15 sine 23. Again, write it more accurate than needed without any rounding, dot, 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 and then round. So 5.861. Well, sorry, 3 significant figures. I've gone decimal places, so I don't need the 1. There we go. Question 6. Tom and Adam have a total of 240 stamps. The ratio of the number of Tom stamps to the number of Adam stamps is 3 to 7. Tom buys some stamps from Adam. The ratio of the number of stamps to the number of Adam stamps is now 3 to 5. How many stamps does Tom buy from Adam? You must show all your working. Okay, so let's start by saying So I'm going to do it like this. So we are starting, so start, and we'll put them down as ratios, and we're doing Tom to Adam is a ratio of 3 to 7. I'm going to leave a line because I might do some working above that, and then we want to end at 3 to 5. Okay, so the number of stamps doesn't increase between these two phases, between the start and the end. So the way that we're going to do it is I'm going to work out how many each one had beforehand. So if I do 240 divided by the number of parts divided by 10, each part is going to be worth 24. So 3 times 24 is going to be 60, 72. And 7 times by 24 is going to be 168. And then afterwards, we're doing 240 divided by 8. So each part is going to be worth 30. So we've got 90 to 150. So that means from there to there should be the same as from there to there in effect. So this has gone up by 18, and this one has gone down by 18. So how many stamps? 18. Question 7. Write this number in standard form. So in effect, we're looking at place value. We've moved from here to here, so we've gone 6, 7 places. So it would be 3.246 times 10 to the, I think I said 7 for the first part. And for the second part, write as an ordinary number. So we're moving the decimal point 3 places that way, or adjusting the place value. As a shortcut, I view when we're going for a -1, we're just putting 3 zeros in the front. So 0.0496. Asma was asked to compare the following two numbers. So we've got two numbers. She says 6.215 is bigger than 4.73, so A is bigger than B. Is Asma correct? No. When comparing numbers in standard form, it's the indice part that's the most important. No, as we'll say 10 to the power 8 is smaller than 10 to the power 9. She should compare power of 10 first. Question 8. So ABC and ACD are right angle triangles. Work out the length of AB. So we want this length. To do that, we can't do this straight away. We need to work at either this length or this length. So if we start planning, this length is going to be quite difficult, but we can do this one quite straightforward. So we're going to be applying trigonometry twice. So the first thing I'm going to do is just change colour. Let's go purple. So I'm going to call this side the opposite and this side the adjacent. So my trig ratio involving O and A is the tan ratio. So tan is equal to opposite over adjacent. The side I'm trying to work out though is the opposite. So opposite is equal to T times A. So now substitute in. So y is going to be equal to 8 tan 45. I'm going to leave it like that for now. I'm then going to work out x. So let's change pen color again. Let's go green this time. Right, so now this is the angle. So this would be the hypotenuse, and this would still be the opposite. So I'll put O in green anyway. So we're using the sine ratio this time, so SOH. And we want to work out H this time. So H is going to be equal to S O over S. Just rearranging that ratio. So x is going to be equal to the opposite side, which was y. So I'm just going to put y for now, divided by sine 20. Right, so x is going to be equal to 8. So let's do it as a fraction, type it in just like it would appear. So I'm going to go 8 tan 45 divided by sine of 20. So 23.3904. So 23.3904 dot 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 to 3 significant figures then, so we're going to this point here, so 23.4. Work out the answer in standard form. So we do have a method where we can divide our numbers and divide our standard form parts, but realistically speaking, your calculator can do this for you. 3.42 times by 10 to the minus 7 divided by 7.5 times by 10 to the minus 6. Right, we may well not get a number in standard form, and we might have to convert it, which is absolutely fine. So I'm just going to say calc equals 0.0456. So then to convert that into standard form, that's going to become 4.56 times by 10 to the minus 2. Right, question 10. Here are the first 6 terms of a quadratic sequence. Find an expression in terms of n for the nth term of this sequence. Right, I'm going to write these numbers again, but give myself a bit of a room, because a quadratic sequence means I'm looking for the second differences. So difference between these two numbers is 6, difference between these two numbers is 10, difference between these two numbers is 14, difference between these two numbers is 18, and then 22. So second differences are 4, 4, 4, 4. So second differences is 4, which must mean that there would be a 2n squared somewhere in my sequence. Right, so I'm going to change colour at this point because I want to actually compare these to these. So 2n squared, well, n squared would be 1, 2 lots of that would be 2, 4 times 2 would be 8, 9 times by 2 would be 18, 16 times by 2 would be 32, and 25 times 2 would be 50, and then 36 times 2 would be 72. Right, to get from here to here, we need to be minusing 3. So these are all 3 bigger than the sequence. So we're looking at the nth term is going to be 2n squared minus 3. That's what we need to do to 2n squared to get to the original term. Question 11. Here is a trapezium drawn on a centimetre grid. On the grid, draw a triangle equal in area to the trapezium. Okay, so let's look at the dimensions of the trapezium. 2, 4, 6, 7, and a height of 4. So the area of this trapezium is going to be equal to a half of 2 plus 7, a plus b, times by 4. I'm going to do the times by half times by 4 is 2. So I'm looking at 2 times by 9. So I'm looking for a triangle of 18. The formula for the area of a triangle is equal to a half of the base times height. So this is going to be 18, so 36 has to be equal to base times height. So any two lengths that multiply together to make 6 would be absolutely, multiply together to make 36 would be absolutely fine. So I'm going to go 6 by 6, nice and straightforward. 2, 4, 6 and 6 high. Keep it as simple. So I could draw a much more complicated one than that, but the reality is nobody's going to be impressed by it. It's just going to make things awkward for your marker. Question 12. So a darts team is going to play a match on Saturday and Sunday. The probability that the team will win on Sunday is 0.45. If they win on Sunday, the probability that they win on Saturday, the probability that they will win on Sunday is 0.67. If they do not win on Saturday, the probability that they win on Sunday is 0.35. Complete the tree diagram. So this is a much more complicated tree diagram than the previous example because we've got different probabilities on. In effect, each pair is going to have a different pair of probabilities. So I'm going to just put information from the question. So that one relates to that one, which is already there. If they win, the probability will be that they win, so 0.67. And then if they lose on Saturday, the probability that they will win on Sunday is 0.35. Right, so I've got all my wins in. Now I need to put all my losses in. They need to add up to 1, so that's got to be 0.55. This has got to be 0.33, and this has got to be 0.65. 0.65. That looks much more like a 6. There we go. Part B, find the probability that the team will win exactly one of the two matches. So that's this branch and this branch. So I'm going to just write down the sum that I'm going to type into my calculator. So that's going to be 0.45 times by 0.33 plus 0.55 times by 0.35. So 0.45 times by 0.33 plus 0.55 times by 0.35. Just double check I've typed everything and read everything correctly. Yep. So that gives me, I'll go decimal, 0.341. Question 13. A biased coin is thrown 60 times. The table shows information about the number that the dice lands on each time. Gethin throws the dice twice. Work out an estimate for the probability that the dice will land on a 6 both times. So we need to come up with a probability based on the relative frequency. So the probability of landing on 6 on both times is 15 out of 60 times by 15 out of 60. So we can treat that as a squared to be fair. So 15 over 60 squared gives us 1 out of 16. Right, Sally is going to throw the same dice n times and record the number of times it lands on each time. The number it lands on each time. She will use her result to work out a more reliable estimate than the probability in part A. What can you say about the value of n? So it will be more accurate provided she does it more times. So it must be greater than 60. And anything that's done more times will be more accurate. So that's what I would go for. Yeah. Right. Question 14. Niobe invests £6,000 for 5 years. The investment gets compound interest of X% per annum. At the end of the 5 years, the investment is worth such and such. Work out the value of X. Okay, so I'm going to say that X percent is going to be a multiplier of Y for now, just because I'm going to work out that value and then convert it into a percentage by kind of minusing 1 and then times it by 100. So whatever the initial investment was, times by the multiplier, which we're calling y for now, to the power of 5 is going to be equal to this final amount Right, so y is going to be equal to 8029.35 divided by 600. And then we want to do the fifth root of whatever answer we get there. So I'm going to say y is equal to, and to be fair, we can type this in as one quite complicated looking thing, so 5. But doing this in 2 steps is absolutely fine. 8029.35, just double checking 35 was right, because I've not written it very well there. Divided by 600. And that looks ridiculously high. And it looks ridiculously high because I missed a 0 here. So if we go back, always sensible to think, does this seem like a realistic answer? So 1.0599999999. So that means that x has got to be equal to 5.99999 ... percent. So we're going to say that that is 6%, which is a much more realistic value. Question 15. Number n is rounded to 2 decimal places. The result is 4.76. Using inequalities, write down the error interval. So if it's been rounded to 4.76, that's as opposed to 4.75 or 4.77. So the smallest number that would be rounded to that instead of that would be 4.755. The largest number that would be rounded to that instead of that would be 4.765. And then using inequality symbols, we would say that n is the value. So that would be our error interval. Question 16, simplify. So we've got algebraic fraction here. I am going to factorise both parts. First of all, we've got a difference of 2 squares on the top line, so x plus 4 and x minus 4. So if I've got something like that, even though it's on top, I will always factorise the easiest thing first, because it gives us a hint for the other one, because we will expect it to either be x plus 4 or x plus 5 in one of them. So let's make that assumption. So that would be 2x and x. And then we're looking for a 4 here, which would mean that we would need a 3 here. So let's put those in for now. And then to make minus 5, it would need to be minus 8 plus 3. So minus 4 there and plus 3 there. They would cancel to leave us with just x plus 4 over 2x plus 3. Make v the subject. Okay, so the issue is v appearing twice. So to do this, I'm going to start by multiplying out through multiplying both sides by v. So that would be wv is equal to 15t minus 30v. I'm then going to take all my v parts over to the left. So that would give me wv minus 30 is equal to 15t. Then I'm going to factorise by taking a factor of v out. So w minus 30 is equal to 15t. And then divide by this bracket. So v is going to be equal to 15t divided by w minus 30. So v is equal to, it's not very clear, they look misreading my own writing. I was just saying that's not very clear. That looks like 156, not 150, and then realised it was t. So w minus 30. Question 17. There are only red counters and blue counters in a bag. Joe takes at random a counter from the bag. The probability that the counter is red is 0.65. Joe puts the counter back into the bag. Mary takes at random a counter from the bag. She puts the counter back into the bag. What's the probability that Joe and Mary take counters of different colours? So that's going to be the probability that Joe takes a red. So let's just sort this out. There are only red and blue counters. So we've got 0.65 to 0.35. So it's going to be, so Joe taking a red counter first of all, and Mary taking a blue counter, plus the opposite, Joe taking a red counter, plus times by Mary taking a red counter. So 0.65 times by 0.35 times 2. So 91 over 200, which would be fine, but as the question is in decimals, I'm going to give my probability as decimal, so 0.455. There are 78 counters in the bag. How many blue counters are there in the bag? So that's going to be 70. Oh, so I'm going to go back to that ratio that I did at the very beginning. We've got red and blue. Red, blue. We've got 0.65 and 0.35. And we've got 78 red counters. So 78 divided by 0.65 times by 0.35. I've missed my decimal there. So 42. Question 18 then. Question 18. There are some small cubes and some large cubes in a bag. The cubes are red or the cubes are yellow. The ratio of number of small cubes to the number of large cubes is 4 to 7. The ratio of the number of red cubes to the number of yellow cubes is 3 to 5. Explain why the least possible numbers of in the bag can be 88. Right. Okay, so if we start by looking at small cubes to large cube, has a ratio of 4 to 7, which means that there are 11 parts to that ratio, so the actual number needs to be a multiple of 11. And then red cubes to yellow cubes, there's 8 parts, so there has to be a multiple of 8. The lowest common multiple of 8 and 11 is 88. So number of cubes must be a multiple of 8 and 11. The LCM of 8 and 11 is 88. So 88 is smallest possible number. Right, all the small cubes are yellow. Work out the least possible number of large yellow cubes in the bag. Right, I'm going to take this then and say small, just to help myself out. Small and large, we've got 4 to 7. Over here, I'm going to say red to yellow is 3 to 5. all the small cubes, so all of these have got to be yellow. Work out the least possible number of large yellow cubes in the bag. So the smallest possible number of yellow cubes, is if we assume 88 to start with. We would need to have 32 and 7 times 8, 56. So we're making the assumption that we've got the smallest number. And if that works, then we'd need to times these by 11, so we'd have 33, and we would have 55 yellow. So we already know of 32 of them being small, so 55 minus 32 is going to be 23. Question 19. A, B, C, D are points on the circumference of a circle with centre O. F, D, E is a tangent to the circle. Show that y minus x is equal to 90. You must give reasons for each stage of your working. Okay, so I'm going to start by saying this. So B, C, D is equal to 180 minus y. And the reason for that is opposite angles of a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral are equal. It's a very dodgy looking Q. So that's my first reason. I can then say that that angle is, so I'm going to say that that there is 180 minus y. And I can also say that that angle there is 180 minus y. So BDF is equal to 180 minus y as well. And that's the alternate segment theorem. And then we can actually say that ODE is equal to 90 degrees, which is equal to, I'll come back to that. And the reason for that is tangent and radius are 90 degrees. So based on that, I can say that 90 is equal to x plus 180 minus y, which means that taking x and y over to the other side, it means that y minus x is equal to 90, which is what we were asked to show. Dylan was asked to give some possible values for x and y. He said that y could be 200 and x could be 110 because 200 minus 110 is equal to 90. Is Dylan correct? You must give a reason for your answer. And it can't be right because y and x are quite clearly so no. So y cannot be a reflex angle. Y is Dylan correct? No. Y cannot. can't be a reflex angle as part of a cyclic quadrilateral. Question 20, 16 to the power of 1/5 times by 2 to the power x is equal to 8 to the 3/4. Work out the exact value of x. Okay, so let's go like this. So 16 is equal to 2 to the power 2, 4, 8, 16, so 2 to the power 4. And 8 is equal to 2 to the power 3. So let's rewrite it as all powers of 2. So 2 to the power 4 to the power of 1/5 times by 2 to the x is equal to 2 to the 3 to the power 3/4. Right, so that's going to give us 2 to the power of 4/5 minus x, which has to be equal to 2 to the power of 9/4. So those powers have to be equal, so I'm going to rewrite it the kind of the opposite way that you would expect, just because I like the way it tidies up better. Right, I'm going to take x over to the other side, so x is going to be equal to 4/5 minus 9/4, and could convert that into an improper fraction. I could subtract those nice and straightforward, but there can't be any marks for that because it's calculator paper, so there's no point. I could put them over 20, but again, I don't get marks for that in this paper. And I've made a mistake somewhere. Let's track back where. Right, so I've made a real stupid mistake up here. We're timesing them, so we add the powers. Not quite sure what I was thinking there. So that's actually 9/4 minus 4/5. Which is going to be the opposite of that, so it's going to be 1.45. So 1.45. Sorry about that. Question 21. Here is a triangle. Find the length of BC correct to 3 significant figures. So BC. So this is a fairly nice cosine rule. So x squared is going to be equal to 11 squared plus 8 squared minus 2 times by 8, 11 times by 8 times by cos of 72. And then I would just type that into my calculator. And I'd say x is equal to the square root of the answer I got from my calculator. So 11 squared plus 8 squared minus 2 times 11 times 8 times cos of 72. And we want to square root my answer. We get 11.42860 dot dot dot. So 3 significant figures, that would be 11.4. Find the area of the triangle ABC. Given your answer to 3 significant figures. So the area is going to be equal to half of AB sine C, so half of 8 times 11 times sine of 72. So 0.5 times by 8 times by 11 times by sine of 72. So we've got 41.8464 dot dot dot. So to three significant figures, we're going 41.8. And unit is there. Okay, question 22. We've got trapezium. Work out the size of the angle CDA. CDA. So I'll call that X for now. Right. Let's think about it. We know that the height of this triangle is 6. What we don't know is this length here at the moment. To work that out, we know that's 24. We know that's 10. Right, so we need to work out this length here. So I'll call that Y. And once we've got that, we should be able to do it. So Y squared is going to be equal to Pythag, 3 sides, 7.5 squared minus 6 squared. So let's just tidy that up. 7.5 squared minus 6 squared. So 7.5 squared minus 6 squared gives us 81 over 4. So Y is going to be equal to 9 over 2, which would be 4.5. Right, so based on that, that length there must be 14.5. So that length there must be 9.5. Right, from here we are working with, let's change pen. This is the opposite and this is the adjacent. So we're using the tan ratio. So TOA, and it is tan that we're trying to work out. So I'll say that X is going to be equal to tan to the minus 1 of the opposite, which is 6 over 9.5. So shift tan, type it in as a fraction, 6. And I've 6 over 9.5. So we're looking at 32.2756 dot dot dot. So to one decimal place, 32.3. Okay, show that simplifies to AX, where A is an integer. Right, okay. So I'm going to start by factorising the top line. X minus 2 divided by I'm not convinced that this will. So earlier in the paper I said that we would have a minus 2 somewhere. I'm not convinced because the minus 2 might appear on the second part, but we'll see. So 2 and 6 would work. So minus 2 and plus 6. And then we're going to, I'll type it in like that for now. X minus 6 divided by X times by X plus 6 times by X minus 6. Right, that will cancel with that. That would cancel with that. So we've got 7 over X plus 6 here. And then dividing by a fraction is the equivalent to multiplying by its reciprocal. And that would cancel with that, leaving us just with 7x. That cancels, simplifies quite nicely in the end. Okay, work out the value of A and the value of N. Okay, so let's tidy this up a little bit straight away. So A to the power of 1 over N times X to the power of 6 over N has to be equal to 7 to the power x to the power 3. Sorry, 7x to the power 3. Right, so we're going to start here. So 6 over n has to be equal to 3. So n must be equal to 2. And then, so a to the power of a half is equal to 7. So what number square rooted gives you 749? There we go. Question 25. Sally uses her calculator to work out the value of a number y. The answer on her calculator began 8.3. Complete the error interval for y. Okay, so this is kind of an example of truncation, but without the word truncation mentioned in it. So we've got to imagine that we've got 8.3 kind of x, and we don't know what the rest of it is. So the very smallest it could be is 8.3. And then the very biggest it could be would be 8.399999999. So we're going to say 8.4 there. And it is that straightforward, really. But that's actually a process called truncation, which is in the spec, but I've very rarely, I think that's the only question I've seen it used. It's it obviously caught quite a lot of students out. Question 26. Here is a rectangle. The length of the rectangle is 7 centimeters longer than the width of the rectangle. 4 of these rectangles are used to make an 8-sided shape. The perimeter of the 8-sided shape is 70. Work out the area of the 8-sided shape. Okay, so I'm going to bring in some algebra straight away. I'm going to call that length x, and then that would be x plus 7. Just for time's sake, I might actually call that y for a moment. So the perimeter of the 8-sided shape is 70. So for the perimeter, we're going to have actually, I'll leave it like that. So that length there is x. So that length there must be 7. That length there must be x plus 7. Then we've got x plus 7, x 7, x plus 7, x and x plus 7. Right, need to be quite careful here. So we've got 1, 2, 3, 4, 5, 6, 7. I've lost count already. 1, starting here. 1, 2, 3, 4, 5, 6, 7, 8x. Plus 1, 2, 3, 4, 5, 6 times 7. Let's double check that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's 6 times 7. And that's going to be equal to 70. So 8x plus 42 is equal to 70. So 8x is going to be equal to 28. So x is going to be equal to 28 divided by 8, which is 8, 16, 3, 3.5. So the dimensions of the rectangle are going to be 3.5 times by 10.5. And in our shape, we've got 1, 2, 3, 4 of them. So, sorry, the area of the 8-sided shape, not the area of this shape. So we're just looking at 3.5 times by 10.5. No, the 8-sided shape, so we need to times that by 4. So 147. So area is equal to, so 147, and we've got our unit in already. Okay, this is actually on the crossover paper. So Ollie drove 56 kilometres from Liverpool to Manchester, and so on. So we will call this part journey 1, this part journey 2, and we'll call the total Manchester Sheffield the total. So journey 1, journey 2, and total. So for any compound meshes question, I find this useful. Speed, distance, time. Right, now if I extract the information, 56 Liverpool to Manchester, so that's 56 distance there, 61 distance there. On his average speed from Liverpool to Manchester was 70, so speed from Manchester to Sheffield, that's, I've got that T in the wrong place. From Manchester to Sheffield, 75 minutes, so that is 1.25 of an hour. Manchester to Sheffield, 1.25. And Ollie's average speed from Liverpool to Manchester was 70. Right, so our goal is to work at average speed for the total. Okay, so the first thing we need to work out is the speed for this journey. No, it's not, it's the time for this journey. So the time for this journey, if speed is equal to distance divided by time, then time is going to be equal to distance divided by speed. So 56 divided by 70, which gives us 0.8, meaning that our total time for the journey is 2.05. Our total distance for the journey is 117. So our total speed for the journey is going to be 115 divided by 2.05. 57.07317. So to work out his average speed, we're going to say 57.1 kilometers per hour. Yep. Jane drove from Barnsley to York. Jane's average speed from Barnsley to Leeds was 80 kilometers per hour. Her average speed from Leeds to York was 60 kilometers per hour. Jane says that the average speed from Barnsley to York can be found by working out the mean of 80 and 60. If Jane is correct, what does this tell you about two parts of the journey? Right. So there are two things that it could imply. You only need one of them. The first one is that the time taken between the two is equal. So time taken between both trips is equal. And then the other bit that it could tell us is that 60 over 80 is the same as 3 over 4. So it could tell us that York is 3/4 the distance to Leeds. So So Leeds to York. York is 3/4 the distance of Barnsley to Leeds. Barnsley to Leeds, yeah. But that top one is the most common answer. Okay, 28. When a buyer's coin is thrown 4 times, the probability of getting 4 heads is 16/81. I work out the probability of getting 4 tails when the coin is thrown 4 times. Okay, so if we call the probability of it landing on a head, if we call it x for now, x to the power 4 is equal to 16/81. So the fourth root of that would be equal to 2/3, right? Fairly sure that's right. Yeah, 2/3. So the probability, so that's the probability of a head. So heads and tails. So we've got 2/3 and 1/3. So the probability of it getting a tail would be, the probability of 4 tails would be 1/3 to the power 4, which would just be 1/81. Okay, and that brings us to the end of this paper. So I hope you found that useful. If we just have a quick look, so like I said earlier in the video, I compiled this from the Edexcel Advanced Skills document. And what's useful about this is it gives us this statistic here, which is really quite useful. So out of the people those questions that were selected, out of all of those people, the average mark for that paper was 37.6. With we'll start at the lower end. People that got 13 marks were awarded a grade 3. You needed 22 marks for a grade 2, 35 for a grade 5, 45 for a grade 6, 55 for a 7, 63 for an 8, and 71 for a 9. So that gives you a kind of an indication of where you're performing on that. If you find that useful, let me know. I find that really interesting. And so finishing off, hope you found that useful. Revision, a reminder again, that is the very likely topics. If you found that quite useful, please check out the good chance paper that sits alongside this, which covers kind of the mid chance, mid to higher chances that haven't fitted on this paper. Thank you very much for your time in watching the video. I hope you found it useful. Again, this is compiled from first class maths topic analysis. Really good, really thorough document, and check out his paper as well. And finally, if you found it useful, please do subscribe if you like. And good luck with your exam.